Okay, today's stream won't be that long. I'm not sure what you're actually seeing. It takes about 30 seconds before I could see the actual live stream, since there's a delay in the streaming. So, I haven't been doing this for more than a month, and this stream is not gonna add up more value than serve as a reminder why you should be constantly practicing, because I was just briefly trying to uh, recall what I did for past few months, and I couldn't, because I wasn't practicing for about a month and I forgot a ton of stuff and things that I was like slightly getting a foothold on. Um, it has turned into a quicksand, and I've lost my footing. I'm not sure if I'm using the terminologies, the analogies, right? But that's roughly the situation that I'm in. I should have been practicing this on a freaking basis, not right before, few hours before I need it, need that particular skill, particular use. I was hoping, like, after all that month's worth of work, I would have at least have some memory cells left in there that would just refire once I see the problem again. Nope, not the case. So this won't be long, as it probably involves me just trying to remember and recall things, and I'll just blaze through a lot of them as always. And yeah, don't be like me. Practice often. That's how you could remember things. I woke up at 5 and I was going through my older videos, and in those videos I sound relatively more confident what I was talking, what the problems. It was very surprising to note that it was only a month ago, or more than a month ago, and now that level dropped like 80%. So it's really hard to pick up the pace once you lose it. So take this as a reminder. I know I won't, because I never learn. Okay, let's go to the problems. So we'll go through a couple of problems. I don't think we'll have time. I probably have less than an hour. Yes, less than an hour to go through about something that would take months. But yeah, it's okay. So we'll start from the very easy ones, because again, this code is probably proprietary. I'm not sure if I'll get a takedown notice from the copyright holders. This is not meant for educative purpose or anything. I'm not trying to make profit out of this yet, so don't take down this just yet. Okay. Let's go. I hope there's nothing crazy on my screen except for the ones that I want you to see. Yeah, seems fine. Let's go. And I really hope the audio is coming in fine, because that can be a problem. Alright, okay, so this is classic maximum subarray. Okay, let's see if I remember this. Given an array of positive numbers and positive number k, find the maximum subarray, maximum contiguous subarray of k. So in this case, Contiguous means continuous, right? Oh no, maximum contiguous means not consecutive, but subarray that gives us the longest subarray. Okay, we could actually take that. Oh man, this I should know this back of my head. So okay, this is the thing. Alright, I don't know why it's in purple, but let's just roll with it. Okay. So there are three ways to approach this. One way is the classic brute force method, where you just do 2 for loops and 2 for loops for I to n, and then from j equals to where I plus 1 to n, and then this is combinatorics, so I'm not sure. Yeah, practice often, kids. This is an easy one. Okay, never mind, forget the combinatorics. Actually, we don't have to. I hope we can still cheat a bit. Okay, so okay. All right. So this is kind of wrong. So this is kind of wrong. So while we go here, for each, what we have to do is just for I to n, from I to n, so 0, 1, 2, 3, 4, 5, from I to n, we just count 3 by 3. So, and for this counting, you have to use for I to for j in j to I plus k plus 1 is my assumption. No, plus 1. Okay, so that's that. I'm not sure why there's not sure why there's no plus 1. Okay, that should have been the brute force methods, but we can do better. We can do better because we are calculating the overlapping parts again and again, summing up again and again. So we keep a sum here equal to 0, and then we loop here and repeat and sum, add to sum each of the numbers. So we'll be summing up 3 numbers every time, so that's kind of redundant. So the optimized way to do that would be to use sliding window pattern, where we keep a pointer of starting window pointer and ending window pointer. as the ending window. So how does the code look like for starting window? And then we just move on. So we just move on, move the start pointer, and then move the end pointer as a okay. Let's start with S and end pointer at the same time. So for no, it has to be S equals to 0. Come on, E equals to 0 as well. So while E is less than len of Jesus Christ, len of array, we keep a sum, we add the sum to, let's say, A, E, and E plus 1. Okay, so then in the next iteration the sum becomes, to the first iteration it's less than, and we add 2 to the array, the sum becomes 2, and then E becomes 2, 0, 1, 2, 3, 4. These are the index. So E becomes 1, and we keep doing this, so it becomes 3, and E becomes 3, and then move on again. E becomes 8. We add that. Okay. So now after that, what we have to do is we have to limit the size of if start index minus end index plus 1 equals to k. So start index, let's say end index is here, start index is still at 0, so it's actually end index minus start index. End index is 2, start index is 0, plus 1 equals to 3. So k we had just now was 3, so equals to 3. Then only then we consider the maximum subarray. So we keep a max so far equals to negative infinity. So we update max so far equals to maximum of max so far over the sum that we have right now. And if E minus S elif, we can do elif plus 1 is more than k, not elif, this occurs independent. Anyway, that's not elif. I hope we understand that part. It's more than k. We have to downsize start, and before we do that, we have to remove that from sum, because it's going out of the window. We're supposed to care for only 3 consecutive items, but let's say in the case E goes here, start to end is this entire thing. So what we have to do is from the sum, so the sum would be 9. So when E goes to index number 3, I3, index number 3, sum will be 9. So what you have to do is just remove 2 from that. to be 7, so you'll only have some of these 3 items, which is which makes sense. So for that we have to move the pointer to S and then remove the starting number from the sum and increment the starting pointer by 1. But the problem that, or confusion that I'm having is like when to place this block. Does it come after or before? So that's usually comes with practice. You probably would know this when you practice enough, because as you see these problems more often, it would be just a hunch or instinct. Now I have to like logically reason through everything in order for this to make sense. Okay, so okay, this would make sense. Okay, now is K, and this would, okay, let's say we start at 0 and at 2, then it would be 8. Then the next iteration, these have to go here in the end. Is it? I think this entire thing has to go there after like a recalibration part, perhaps. But this is essentially the code. Yeah, I don't think I'm gonna have a good time. Man, oh man. But the best way when you're stuck, just walk through examples. It's gonna take a bit more time, but that's gonna help you when you don't have any hints. So let's say S at 0, E at 2, the sum would be 8, and then we move on to the next iteration, E equals to 3. What we have to do is this has to be done first. So we evaluate S minus the window size is more than K. So what we do, we reduce the starting pointer, and then reduce the starting pointer. We reduce the starting pointer. Yeah, we reduce the starting pointer, and then we move here, and then the sum becomes 7. Does the sum become 7 yet? Or yeah, the sum becomes 9 first. If you do it at the top, the sum becomes 9, and then we deduct by 2, and then we consider only 7 afterwards. So that would work. Okay, sum is 7. Then we move again, and then the window matches to the case over here. So we save it to the maximum so far. Earlier it was 8 would have been saved. 7 is now more than max, so we don't save it. And then E moves to 4. E moves to 4, but then it is larger. So what we do, we deduct the sum, and then move the end pointer, and then when we evaluate, we add up the new number, which is 3. It will be 10, and then the window size is exactly 3. So what we do, we compare with this max so far. Max so far is 8. Now this becomes a max so far, and then we do that again until it becomes a thing. So what is the order? I think this this part can go here. This is in the middle, this is the end. We only evaluate at the end. How wrong am I? This is essentially what I've been saying. They only use one if, because the code is optimized. They always do this. So Windows end. Okay, so the window end has to go all the way till the end. Sum, we add the window, and window size is more than window, or more than or equals to. So we just, oh wow, we don't evaluate. We don't even have to evaluate. Okay, but it's kind of similar. We manually do this, so we just add the sum, and we only evaluate when the window size is of k. Okay, so another invariant that we can, so this is like unoptimized. Another invariant that we could, I probably would have had this movement previously, but I forgot about it. Now I'm literally learning stuff and getting inspired. This is, I mean, Alzheimer's isn't bad. You always learn new things every day if you have Alzheimer's, even though it's the old thing that you've done for like ages. Okay. So what do we do? So what they optimize is, if you observe, once we pass, so let's say the k is 3, right? So once we pass k minus 1, which is 2, for every other number, for every other index, we have to move the window's size. We have to move the starting pointer. So instead of like checking every time if it's outside the window, we could just say, hey, if it's more than the window size, I don't know what I did, I don't know how I moved it. Okay, if it's more than the window size, we always adjust sorry, window. Okay, decrement sum, evaluate. This is highly optimized. How long did that took me? Probably 20 minutes. I think I spent 3 minutes blabbering about stuff, and then we've been doing this for 20 minutes. Okay, let's move on to the next question. Practice often, kids, practice often. This is another easy one, but I'm sure I'll screw this up. Smallest contiguous subarray of cases. Maybe you don't have to like do all this. Maybe you don't have time. Maybe we don't have time. We definitely don't have time. Okay, let's what's the question again? Smallest subarray. Smallest contiguous subarray with sum greater than or equal to s. Greater than or equals to s. And s in this case is 7. And s equals to 7. Gotta love the font. S equals 7. How are we gonna do this? Since this is a sliding window problem, I would assume that it has a couple of pointers. Brute force is similar to the one that we had before. Excuse me. we would just do 2 loops, and then for the size of, okay, this is different from the previous one. The previous one had a fixed window size. This one does not. So for this one, the window size is not fixed, so you have to dynamically evaluate every time. So the method that we used in previous method would, the method that we used in previous question would be useful in this one, as we have to evaluate constantly. Are we no, there's no constraint. I'm sleepy. Oh my god. I really hope no one sees this. Okay. What we do. Smallest window with some larger than S. Okay. So we keep adding, we increment E while E less than len of A, we sum equals to 0, sum plus equal A E. We increment the sum as long as it's less than length, and if sum larger than or equals to 7, so the answer is supposed to be the window size, so we probably have to track the window size. So min window size MWS equals to negative positive infinity, so it's really large. So we have to minimum window size equals to minimum of ending pointer minus starting pointer plus 1. So once the sum is larger than 7, there's no need for us to keep the starting point at the beginning. So what we can do is increment the starting pointer. So let's trace through the algorithm. So another problem I think that I'm going to have, I'm writing the code. I'm straight away jumping into the code without thinking about the algorithm first. Okay. So let's say starting ending pointer, we move start ending pointer here. The sum would be 3. Okay. We refer to first round iteration is 2, second iteration is 3. And that doesn't meet the criteria. No. Then we move to third ending, so then suddenly 8, so it meets the criteria. So the minimum window size so far is 3, but you can actually do we can decrement the window size by variable amount. So let's say when you have 2 1 1 1 1 1 1 5, you can actually reduce to 1 1 5. You can actually reduce the window size up to just 2, but in this case if you just reduce it by 1, you would have longer subarray. So for that we probably need another while loop where while sum equals to, sum is less than, sum is more than equals to 7, is we deduct the sum, and then we decrement the s starting pointer. So this would force the window to be small as possible. This is weird. Okay, I just give up. I can't give up. Okay, let's. The important idea is, I do have a beginner's mindset. Don't get annoyed when you don't know the solution to problems straight away. But given the constraints that I'm in, which is time and the importance, it's frustrating. It's, yeah. Screw that. Okay, start and move by 1, keep a sum, and then here sum equals to 2 and sum equals to 3, and then we move here, sum equals to 8. So now that sum equals to 8, we get a bit of bandwidth to downsize the window. The window size so far is 3. Can we shorten up and still have the same window size? So you probably, I forgot to turn off my notifications. But, oh shit, it's going to be 8. I'll stop the stream at 8. Oh my god. Is anyone else on the live stream? If you know me, do yourself a favor, don't watch my live streams. Though I would appreciate if you don't. It's just a PSA. Which means you don't have to follow it. Okay, never mind. Alright, let's go back to our problem. So, we're here. Sum is 8. So what we do is, while sum is more than equals to, we do while the sum is more than or equals to k, which is, no, it's not k anymore, it's s. We reduce the sum a e, and starting pointer increases by 1. So we just downsize. So here now it's sum equals smaller than greater than s equals to 7, so s equals 7, so and the sum equals to 8. So we remove the first number. So the first number is 2, so it removes 2, 6, and then we move the pointer by 1. So starter is here and then it's here. The sum is no longer 7, so this while loop breaks, and then we move on to the next one. The end pointer moves here. We calculate the sum. We add the sum. It becomes 8 again, so this loop gets triggered, and we move the pointer. We remove 1, 7, still true. The pointer is here. Actually, we have to filter if sum minus a e is more than s. If we remove sum minus as, if we remove the starting pointer, would our sum be still larger? If then we remove, so otherwise it's not gonna work. Okay, so then we move the pointer here. And if you minus this pointer, the sum is 7, but if we minus this number, if we minus 5 from 7, is it going to be larger than 7 or equal to 7? No. So this loop will break, and then our minimum size so far, you have to keep, of course, you have to keep track of the minimum window size. In that case, the minimum window size so far previously was 3 when this was the case, and these other two did not meet the criteria, so minimum window size would have been 3, so we have to do another minimum, which is now 2, so the 2 will win, and you will get your answer over here, I would assume. We have not even scratched the surface. We're just still doing shitty sliding window. We have not touched BFS, GFS, heaps, cyclic sort, merge intervals, all the fun stuff. But I think I should start wrapping up this stream and spend some time on other topics while I realize. So doing these two problems gave me a late lesson, but nevertheless a lesson that I will forget and discard. That you should practice consistently. Yeah, it's pretty late. Anyway, so the takeaway from this video should be go back to the previous videos, previous live streams, and watch those attempts, and then come back and watch this one. Though it's probably around 1 or 2 months apart, and you'll notice the difference. And based on that observation, make what you will. I think I've been doing a lot of monologues and trying to give advice as if I'm giving this to someone else. But in reality, I'm just telling this to myself, not anyone else. I just want to see my remorseful face few months from now, and I'm in the similar situation, and question myself, hey, why didn't I listen to this wise guy's advice? Wise because of the circumstances, not because I was proactively doing something, and then because of that. Wise. Wise because of the experience, what made you regret. And I don't know if regret counts as wisdom, but it does for me. Alright, enough with that. This is pretty short, 40 minutes mark. We just crossed 40-minute mark, and I'm gonna do some bit more prep. And hopefully, hopefully, there are also some other things going on the side.